and as I mentioned, she's going to share her learnings and Ericsson's learnings on working with the challenges of data quality. So Sima, please take it away.
Thank you very much, Jan. I really appreciate this invitation. It's really a privilege for me to be here. So, as Jan mentioned, I'm a senior data scientist in Ericsson. And today I'm going to share with you some of the experiences and challenges we had regarding data quality and the steps we actually took and we are still taking in this path. Before starting, I actually would like to somehow motivate you. Why should you care about data quality, so that I'm actually confident you are following me up to the last slide. Most of the human and machine decision makings, they are based on data, they are backed by data, and the quality of those decisions is basically as good as the data they are based on, which means if the data is incorrect, if the data is incomplete, so is the decision. So this would impact decision making and business strategy in negative way. It will be also impacting the performance of the machine learning if the teams are working on those aspects. In addition, poor data quality would decrease productivity, and it would actually introduce some sort of inefficiencies and increase operational costs with the organization. To just make it a little bit clear, think about your data analyst or a data scientist, that they should actually put majority of their time to just find and solve the issues they actually see in the data they are working with. So this time should be actually somehow dedicated it should be dedicated to higher value tasks, but they need to put this time for just cleaning up the data. Some research shows that 1/3 of this type of employees put 40% of their time just to deal with the data issues they are facing to. And in addition to what I mentioned, you can imagine that when employees are actually dealing with data dilemma every day on daily basis, every now and then, they decide to actually solve the problems in quick way, not really resolving the root cause, but just solving it in a really fast way, to just deal with, pressures like deadlines. And what does it mean? This actually would increase the likelihood that this type of human error would penetrate into your system, and then it would cause more problem later on down the line. Beside what we have talked about, decreased productivity and impact on the performance and decision making, we can think about emotional consequences of poor data quality. Say that some data scientists or data analysts, they are hired to work with high-skilled works, but then they are forced actually to work or deal with incomplete, inconsistent, and inaccurate data. So they probably wouldn't find it that much satisfying. It would make it really difficult for them and frustrating to put their time on the task that they, in the first place, they didn't really imagine that they are going to work with. And on the other hand, when you are applying this type of local treatments to data to solve the issues, when your teams are working with the data quality issues in local way, it might be that your organization ends up in several sources of truth, and it's likely that different teams actually disagree on what is the correct result, what is the correct data, and which conclusion they should trust on, and what is reliable at the end. But this type of consequences is not just limited to the organization and its employees. It can also impact the client and customers if the data quality issue is related to the data which is belong to customers. And we know that managing the client satisfaction is really, really crucial. And even one bad review or bad experience can be very, very demanding for the companies. So I hope that I could convince you that poor data quality issues has really different consequences for our organization. But in next slide, I try to just bring up some of the statistics and values that you can probably Google and find here and there, just to emphasize the cost of poor data quality. The average organization is losing or was losing $13.5 millions of dollars per year as a result of poor data quality. This is what Gartner has actually announced in 2015. It's a really huge amount of money. 25% of companies in US do not trust the accuracy of their data. So this was something reported in 2013. Hopefully this is really changed. And then 60% of the time, the barrier to use data effectively is related to lack of quality. This is something reported in 2014. And 84% of CEOs worry about the quality of the data within their organization. So this is more recent, is 2016. So I think we could actually capture the significance of data quality somehow up to here. Before going ahead, I would like to talk about causes of poor data quality. Here, this list could be really, really wrong. I just wanted to come up with the ones that we could see is valid, and we could valid for Ericsson, and we could really have some sort of personal or organizational experience about it. So human error is the first one, and this has been actually the most effective cause in many other areas. Human error could be, in the first place where you actually enter the data. Still, Ericsson, like many type of organization, has some sort of manual data creation. It could be related to configuration data, where people are entering the configuration information manually into the system. So there could be problems, typos, and other things. So that would impact the quality of data. We still are using some sort of a spreadsheet within the organization, especially when it comes to A/B testing. I can bring some examples for you. Ericsson actually is running A/B testing when it comes to deployment of new software. So they usually we have operators that they are collaborating with us. They actually have part of their network dedicated to continuous deployment, and we actually get list of nodes and cells which are part of this. We know which one are controlled, which one are under test, and then so this is a spreadsheet we get, and then on the other hand we can fetch the data from the network management system within the field. We try to somehow merge these two pieces of information and then see which data we should work to compare the test and the control population. And this spreadsheets, first of all, is actually created manually. So you can imagine that it might be incomplete, it may have some errors, and this could at the end impact the significance of the result you are looking at. But then this type of a spreadsheet also could be prone to data decay, because it could be that the last 2 weeks they decided to move some of the nodes out of this population and import some other nodes, and we don't really get this information automatically. So usually there is a process that you should request, and then you should get the result back. So I would say that sorry. Okay.
It sounded like there was a question, but I don't know if someone had forgotten to mute. Is there a question? If not, Sami, we just continue.
Okay. So then we talked about human error that could be actually in the first place, which is the manual entries of the data points to the databases, but it could be also in the preparation of the data. I mean, usually we see that, I mean, this is happening so much that they're dropping the data when they try to deduplicate the data. Sometimes they are duplicating the data when they are trying to consolidate and enrich the data. And it also could happen further on in the pipeline when they are trying to write the code. So this problem could actually impact us in different places. The second source of poor data quality we can see is in system challenges. I mean, especially for us, I mean, at least the operational unit I'm working with, we get the data from operators network, and this is through the network management system. Sometimes they have the migration, they are migrating from one network management to other network management system, or they decide instead of delivering one file, delivering several files while our data collection team was just looking for that specific file. The data was actually broken to several files, so we are missing, some percentage of the network without knowing that, and this goes on and on until we discover it somewhere else. And I talked already about data decays that you may have Excel sheets or other pieces of information that they have been valid, last month or 2 weeks ago, but they are not valid anymore today. And of course, I should also add the new sources of data here. I didn't put it here, but sometimes you are working with, different data sources that they are completely aligned, but then you get a new data which might be slightly different, but your assumption, your default assumption is that they are the same, and then you just ignore checking this, the quality issues. So up to now, I hope that I could really convince you that the quality matters. So we should find a strategy to check for quality. So let me start to bring up how we should think about quality assurance strategy for data. So I start with software quality assurance to just find the similarities. When you look at the software quality assurance in context of software engineering, we come up with testing a strategy. And testing a strategy basically is a response to several valid questions one can ask. The first question could be, I have created a new function or module. Is it working? Is it really functioning as it should be? So the result of that question is usually a unit test. So you actually provide a unit test to see if the module functions as it was designed for. And then the next question, the next valid question would be integration test. Would bring the integration test, because you would ask, now I have this new function or I have this new module, how this function or module would work with other modules and functions that I had. So you are checking the interfaces between these functions, and that is integration test. The next step would be, okay, how the whole system is working now. Is it complying to the requirements I have put in place? And that would result in system tests. And at the end, you would actually look at the system from end user's perspective, and you would ask yourself if this is something that the user is needing and willing to use. And then that would be actually your acceptance test. And this is necessary because usually when it comes to developing a new software, we go to infinite loop of discussion and changing the criteria or requirements. And it's really good to have this acceptance test to be sure that we are still aligned with the first thoughts we had about this product or this application. So now I'll try to have the same sort of questions about data quality so that we can bring the quality assurance up. So when it comes to data, it might be that you have a database which has 1,000 columns of information, but you are just interested in 10 or 20 of them because you are working with machine learning algorithm, or you are working with analysis, which is just concerned about those 20 columns. Those columns would be called critical data elements. They are subject to data quality, so that you are not really looking at everything. So one can look at the CDE or critical data element and ask different questions. Is it complete? Is it valid? Is it consistent? Is it unique? Is it accurate? And is it on time? And these questions, this valid question, should have responses, and those responses would make your strategy for data quality assurance. So the 6 common pillars of data quality assurance is completeness, conformity, consistency, uniqueness, accuracy, and timeliness. But of course, this is really something depending on the type of the data that you are dealing with. You may need just few of these, or you may need actually to add some few to cover what you are targeting. Before continuing, I would like to share with you some of the personal experiences I had within my team, so that we came to conclusion that data quality is something that we for sure should go for. So I start with the first story. Let me just bring my pointers up. It was almost a year ago that we have started to, or perhaps more, we have started actually with creating developing a KPI, which was taking so many contours and attributes into account to calculate something which would be meaningful for our networks. So we were in the proof of concept phase. So we were actually working with the algorithm itself, and at the same time we were trying to onboard different networks or operators into the system. And during that interval, probably you have so many data with onboarded data, onboarded customers, and you have problem with algorithm itself. So you don't really have the opportunity to investigate exactly what is happening in your result and why it's happening. So if you see here, you see that, over time we were onboarding operators, so they were coming, so showing some values, but there is one specific color here or operator that it comes really, really late. So this is actually, the fact is that this customer really didn't show up or onboarded here. It was somewhere here, but we didn't really have the result for this customer for a while. So the information was missing, and we didn't notice that until somewhere here that this customer doesn't show up, and we should find out why. Since we were on the poker phase, and usually, as I mentioned, you have so much problem, the first reaction you have is that probably this customer doesn't have these counters on, or perhaps one of these counters is missing, or perhaps one of the attributes is not in place, so we really need all of that. So we were thinking that the data is not complete. And we were hammering our data collection team and the operator that you are not sending us the data that we need, so that's why we can't create what we are actually willing to. But then they came back with the information that, no, we are sending everything to you, so this should be in your site. And then we started our investigation. I think this should be really familiar pipeline for many of you. So we actually have the engineering part, data collection part, and so forth. They actually bring the data into our clusters, and then we have preparation, which could be ingestion, parsing, and saving in different formats. And then it could be also enriching the data, merging different databases together. And then we have the analytics on top of that. So one of the activities we started to perform during that time was, okay, now we should understand where does the data loss happens in our system. So basically you start to see if the data was in place in XML files. Yes, it was there. So what has happened when we have done ingestion and parsing and preparation? Was it there? Yes, it was there. So then we have the data going into analytics. So why it does not come out into reporting? And then we realized that this should be somewhere in the coding that we are working with. And it took really long time. I mean, perhaps 1 week or so to go through 100 lines of code to understand what's happening. And this was the finding. One of the attributes we were working with was categorical attribute. And usually all the operators are using either 0, 1, 2 up to 5. So they are using the digits. But this customer I showed you decided to use the text. And our code was not capable of catching that information. This is a conformity problem. So the type of the, I mean, if you would check it in data quality from the beginning, we could see that the type of the data doesn't really conform to what we are expecting. This is not a digit, and we could realize it in the beginning before going through that long investigation, and also hammering our operator for not sending us the valid data we needed. So this was the first, one of the first occasions that we realized that, if you are missing data, it could be easy, but when we have these small things, this is not really easy to find, and this is not really easy to actually respect the, the other parties which are involved in this process. The next time is still the same KPI, but another actually event. Me and one of my colleagues was looking at these graphs after some while, because it's not like that always we are sitting in front of monitor and we are checking which KPIs we have created and so forth. And we noticed that for one of the operators, we have really significant improvement in KPI, around 10%, and this happens just in no time. And probably this is not really, this is not something which absorbs attention of one, junior data scientist or junior software developer, because they are looking at curves and they are in place and it's good. But when we are looking at this, we know, oh, this is not possible. What they have done into their network that they could really improve this KPI 10%. And then the result of this was going back to the data and realizing that in this interval, actually, we were missing 50% of our network and we didn't know about it. This is like, I provide you with a database and I say, this is the housing price in Sweden. Please calculate me the average house price in Sweden. And then you do that, and then later on we realized that you were missing some information, and this information was not random. It was, for example, just a specific part of your distribution. It was, for example, Stockholm, and then now you know that what the data you are working is not representative of what you are trying to actually represent. So this is really a big problem. So this was the second time we understood that we really need to have something in place to be sure that what we are creating like this is meaningful. We are not really providing our customers with something which is full of error, and it may really impact their decision making and the strategy they take ahead. Just before going forward, I want to talk a little bit about the last, the last aspect, the completeness of data, a little bit more. And for that, I need to introduce what we are working with in Ericsson in my unit, so that it becomes a little bit more clear for you. The data we are working, it has 3 dimensions. So we are interested in elements that they are in the network. So we have network size. For each of those elements, we have a bunch of counters and configuration attributes. When it comes to counters, I'm talking about several thousands. And when it comes to attributes, I'm talking about several hundreds of those. And then the time aspect is in place. So when we talk about completeness, we are meaning that for a specific element, I should have all the counters and attributes that I need, but also those counters and attributes should be available for the time that I'm actually investigating. But this is not the whole story. I should be sure that all network elements are in place. And this is really challenging question for us. How complete is the data in respect to network size in the presence of missing data? What is the total size of your network while you know that operators are, continuously changing their networks. They are moving from 3G to 4G. They are moving from 4G to 5G. Probably now they actually have some sort of a throughput issue somewhere. They are deploying new frequency layers and so forth. How do you know that network size is complete? Because if you miss the whole data, this is okay. You don't get anything and you know that you have missed the data. But when you just miss part of the network, as I showed you in the previous slides, this is so difficult to cope with. And then if this missing data is not random, as I mentioned before, it could really impact the result you get. So for us, we realize that it's so vital to create some sort of reliable baseline in order to estimate the degree of completeness. We need something. We need something to compare our results with. I mean, it's not easy to just imagine that the data is complete. Now we go to data quality process that we are using currently in Ericsson, at least in several operational units. This process is something which is recommended and you can find it in literatures, but we have applied some sort of modification here, which is baseline, creating baseline that I talked with. So the first step in data quality process is profiling the data. You are looking at your data and you look to see which type of data they are, what are their ranges, what are the frequencies. You can do distinct count, you can find the percentages, you can find the percentage of zeros, blank values, null values, minimum, maximum, and so forth. But this is not enough for us because the percentage doesn't say anything to me when I don't know what is the total population. So we need also to provide some sort of reliable baseline. And then in the next step, you define your requirements, data quality requirements. What is your requirement when it comes to completeness, conformity, timeliness, and so forth. So you make sure that this is aligned with the objectives you have in your machine learning applications or your benchmarking application or whatever type of analytics you are working with. And then you conduct this data quality assessment. So people who are working with code, they try to enforce these data quality criteria. And based on that, you may actually identify some data quality issues. And this is a good opportunity to put those issues into your data quality backlog. And later you can actually, in the next step, start to look at those issues. You can investigate why this is a problem, you can solve it, and then also you can, based on the lessons you learn, you can review and update the policies you have for the data and for your procedures. But the last part, monitor and control, this is the part I would like to emphasize very much. We realize that whatever you do here, you really need to monitor all the time. So we define and design data quality score cards and verdict dashboards for all of the things we are doing in this area. I will show some of the examples to you later on. And then we also try to automate some of the events if some of the deviation happens. It's like anomaly detection, so we can actually make some sort of automatic email sent or whatever, so we know that something is wrong. This process is not really one-time process, so we need actually to iterate all the time to be sure that everything is placed. So you actually iterate through this cycle several times. Just one question, Jan, how many minutes I have? I just want to be sure that I'm wrapping up. Can I know how many minutes I have?
Yeah, so it's 47. You're supposed to talk, I think, until 15:45. But since my closing will be relatively short, if you take a few more minutes, that's perfectly fine.
Okay, great. Thank you very much. Sorry for. So I think I just wanted to show you here. I mean, you see the results with and without applying the data quality rules. And here one would wonder why we see so much variation, why is really low here, this KPI going up. But now we are so relaxed, we can see that everything is automated and what we get is neat and clean at the end. one recommendation is that we are doing this profiling and monitoring in all the steps. It's not just in the data entry point. We do this whenever we actually apply any type of treatment to the data. So we want to be sure that the data stays healthy and complete all the way. Here is just, I wanted to show you the monitoring that we do. I mean, we monitor even the profiling we do, the baseline we create. We also populate our verdict dashboards to with our data quality assessment, so that if something happens, we can easily go back here and see, here I didn't really have data quality in place, but here the data is reliable, so forth. So it's easy for me and other colleagues to understand what's going on in the data. So it's about the improvement of data quality. I mean, this is something that we have tried to do it in our team, but now I see that Ericsson does it in really higher level. So we have started to invest in data quality management. So we took it as a priority. We started to talk about it, and we actually put some time and some effort to work on data quality so that our action could be louder than our words. We started to put policies around the data entry so that we can be sure that we are preventing poor data quality in first place. And then we also started to change our culture regarding data quality. We actually we talk about it rather as a priority. We actually put time and effort for it. We get people involved. We actually ask for collaboration and cooperation. We acknowledge the achievements, and we state that this is ongoing priority. This is not really one-time task. And now, in higher level, Ericsson actually recently has established a data enablement office, which has the responsibility to democratize data and break down silos so that all people actually within Ericsson have access to use the data freely. They are also responsible to to create clear accountability for data, to be sure that they are relevant for the business cases we are working with. And one of their responsibilities, as you see, is improving data quality to foster trust and reliability. They are using federated data operating models. They are letting the operational units to own the data and to collaborate with the DEO so that they can actually work on different areas, especially data quality. Because if one person comes from other part of organization and wants to use your data for a small type of research, they really may not have the time or even the feasibility to check for lineage and quality and so forth. So this is usually the responsibility of the operational team and their data stewards to help DEO to come up with this definition and assurance. And just to conclude my word, this is not really advertisement for Ericsson, but I wanted to show how far Ericsson took this culture. So it's really investing on data quality, and I have the privilege to see that Ericsson for the first time is actually put some ad out for employing data quality expert. So Ericsson as a whole taking so many big steps to be sure that we have a good culture around data quality and we have a reliable data in place. Thank you very much.
Wonderful. Thank you so much for sharing your experiences and insights with us, Sima. This is where we open the floor for questions. As I stressed, many companies in the Software Center I know are struggling with the challenges associated with data quality. So even if you don't have questions, but you have some anecdotes from your own organization to share, feel free to share them with us. Not all at the same time, people. Yeah, so let me ask you a question then, Sima. You can still hear me, right?
Yes, yes.
Yeah, very good. We've been doing some work between Lucy and Aishwarya. I'm not sure if you've met them at Ericsson. And one of the things that we've been looking at, and I know that Lucy's in the call, but I don't know if Lucy wants to jump in or not, is this notion of a data linter, which is basically a solution that you put in a data stream in order to, at runtime, detect whether data is missing or data elements are missing, data elements are out of bounds, whether when you look at a window over a certain data stream, the statistical distribution of the data is starting to shift, or any type of validation that you can do on a data stream. Is this, I suppose that this is what you are spending your time on as well, trying to identify when there are problems in the data and then triggering mitigation strategies to address this. Is that a correct? Can you reflect and share some of your insights on this?
So see, do you hear me? Or
yes, we can.
So I would say this is part of what we are doing, yes. But if I go back to this slide, probably, I mean, when I took this network size, perhaps I can start here. The problem is that how do you know over time you are missing things? Of course, I mean, if you are missing a counter for a specific element, that is one of the things we do. I mean, we look for elements and we see if you are missing counter or whatever, that is okay. But tracking of the elements over time, this is really tricky part for us, and we would be happy if we have any help in this area. Right, and this is a fact that we are working with complex, scenarios, because if you think about 3G, it's a declining network, so they are really dismissing network elements. But when it comes to 5G, they are populating this network. When it comes to 4G, depending on which customer we are talking, it might be more stable, or it could be they are just new to Ericsson, so they are actually ramping up. So we have different scenarios, and then when you don't see one element that you have been seeing yesterday, you don't know if this is really a missing piece of information, or this is something that they decided to just dismiss.
Right.
So this is one problem. The other problem is that it's still easy for us to actually track things, because if you see in this figure, sometimes, so see where I am, sometimes even they change the definition of subnetwork and so forth. So you see here the colors has changed over time. So they were actually migrating from some sort of network management to others, and in the same time they were changing the definition of subnetworks and so forth, which is really important for us to identify one element. We know the elements based on their subnetworks and other type of information, and when the subnetwork is missing or changing over time, then it's so difficult to understand if it has been in place, if this is a new thing or what. So different aspect, and here you see not only we are missing data, you see that this is an increasing, if you see my mouse, this is an increasing it's increasing number of elements in the network we can distinguish. So if you compare it with something here or here, this is not enough, because actually you neglected part of the network. So the tricky part, and what you mentioned is correct, but what is tricky for us is actually to capture the completeness of the data. And I'm not really sure how other companies are solving that problem, if they have similar problem, or for them the population is so transparent, so they know that what they are talking about. So what you mentioned is correct, but we are also concentrating heavily in this part.
Right. No, I can see that, and that was a great reflection, Sima. Thank you very much for doing that.